Okay guys, good evening and welcome back to electric circuits. So far we have looked at what resistive circuits. So far we have been looking at what resistive circuits. That means what all the circuits, they only contain resistors along with independent and dependent sources. Okay, but apart from the resistor, there are two other very common circuit elements, namely the capacitor and the inductor. Now what is the fundamental difference between a resistor and these two elements, that is what the capacitor and the inductor? You see, resistor always dissipates energy. Any resistor, it will always dissipate energy in the form of what? Heat and so on. So whenever current flows through what? A resistor, always that resistor will dissipate energy in the form of what? Heat. And the power dissipated by the resistor is what? I square into R, which is always positive. So power absorbed by any resistor is what? I square into R, which is positive. But when it comes to capacitor and inductor, both can store energy, whereas a resistor will always dissipate energy in the form of what? Heat. But a capacitor or an inductor both can store energy, and whatever energy is already stored in the capacitor or in the inductor, that can be given back to the circuit. This is very important. Whatever energy is already stored in the capacitor or the inductor, that energy which is already stored, it can be given back to the circuit and so on. So that is the fundamental difference between a resistor on one side and a capacitor or the inductor on the other side. Okay. So first, let us discuss a few important things about a capacitor. First and foremost, how do you make a capacitor, or what is the easiest way to make a capacitor? Take two conducting plates. Yes or no? Take two conducting plates, and in between the two plates you put some dielectric. Dielectric means what? Some insulating material. You have what? A capacitor. Okay. So what did I say? The easiest way to make a capacitor is to take two conducting plates. Okay. So these two yellow color plates, they are what? Two conducting plates, in between which we have in between these two conducting plates, you have to put some dielectric. Okay. So this blue color material between the two yellow color plates, it is what? Dielectric. Okay. What is dielectric? Dielectric is what? Any insulating material. Through any dielectric, ideally no current will flow. Through the dielectric, electrons cannot flow from one side to the other side and so on. That's all. So whenever you have some insulating material between two conducting plates, we have what? A capacitor. Okay. So how many plates are there? There are two plates, the two yellow color plates, one at the top, the other one at the bottom. Now for these two plates, you should connect what? Two contacts or two terminals. Then you have the actual circuit element, because our circuit elements contain what? Two terminals, right? Or two or more terminals. Resistor, it contains what? Two terminals. Voltage source, it contains what? Two terminals. Transistor, it contains what? Three terminals, or maybe even four terminals, depending on what type of transistor we are looking at. There can be two or more terminals for any device. Okay. So even for the capacitor, all of you know, there are going to be two terminals, but right now I have not shown the two terminals, right? So what you have to do, you should take two wires. You should take two wires, stick one wire to the top plate and stick another wire to the bottom plate. So these two white color wires, they will form what? The two terminals of the capacitor. Okay. So there is what? One terminal. There is what? The other terminal of the capacitor. So number one, take two conducting plates. In between the two conducting plates, you should put some insulating material, that is what? Some dielectric. And the best example for dielectric is what? Silicon dioxide. Best example for Dielectric is what? Silicon dioxide. So inside your smartphones, you have what? The chip, and inside the chip you have what? Number of capacitors, and for all those capacitors the dielectric is what? The silicon dioxide. Okay, so in brackets let me write this is the most widely used dielectric material, that is what? Silicon dioxide, especially when it comes to what? Integrated circuits. Okay, anyway, so the two yellow color things are what? The two conducting plates, and these two white color wires are what? The two terminals of the capacitor. Now what is the property of any capacitor? Capacitor, it stores what? Charge. What is the property of any capacitor? It stores charge. Okay, that is the fundamental property of any capacitor. In fact, in any circuit, in any system, if there is a property or a phenomenon due to which charge is what? Being stored at some location, then we associate what? Some capacitance with the region where charge is what? Being stored. Always charge storage is related to what? Capacitance. Whenever there is charge storage, we always say there is some capacitance. Okay, so capacitor, it fundamentally stores what? Charge. So even this capacitor, it will store some charge. Okay, now for the capacitor, clearly there are two terminals, right? There are two terminals. If you apply a voltage across the capacitor, what is that voltage across the cap denoted by Vc? So Vc is what? Voltage across the capacitor. Now look at the voltage across the cap. Voltage is what? Potential difference. Voltage is what? Potential difference. So is Vc, is it not the potential difference between the top plate and the bottom plate? Why? Because plus is marked towards what? The top plate, minus marked towards what? The bottom plate. Vc is what? The potential difference between the top plate and the bottom plate. So from now onwards, always Vc will stand for the voltage across the cap. Okay, so Vc, it is what? Voltage across the capacitor, or simply the cap. So capacitor, it stores what? Charge, and Vc is what? The voltage across the cap, and voltage across the cap is nothing but the potential difference between the two plates of the capacitor. In this case, Vc is what? The potential difference between the top plate and the bottom plate. Okay, now usually this is called as what? A parallel plate capacitor. By the way, the capacitor shown here, it is what? A parallel plate capacitor, because there are two conducting plates which are parallel to each other, and in between the two conducting plates we got this blue color material, that is what? The dielectric or the insulating material. So that is why it is called as what? A parallel plate capacitor. And for a parallel plate capacitor, always the two plates will carry what? Equal and opposite charge. Two plates will carry equal and opposite charge. This is true for any parallel plate capacitor. Both the plates will carry equal and opposite charge. Let us say the top plate. Which plate is positive? I mean, plus is what? Marked at the top plate, minus marked at the bottom plate. So you should say top plate is what? The positive plate, and the bottom plate is what? Negative plate. Of course, we are assuming that the value, the voltage drop is what? Positive. Vc is what? Positive. Then top plate will be at a higher potential compared to the bottom plate. Top plate, higher potential compared to bottom plate. Top plate will be called as what? The positive plate, and bottom plate will be called as what? The negative plate for this case. Okay, and I am saying what? That for any parallel plate capacitor, both the plates will always carry the same amount of charge but opposite. I mean, they carry what? Equal and opposite charge. That means, for example, let's say the top plate carries what? A charge of plus 10 coulombs. What is the unit of charge? Coulombs, right? Yes. Let us say the top plate has a charge of what? Plus 10 coulombs. Then the charge on the bottom plate must be what? Minus 10 coulombs. So both the plates of the capacitor carry equal and opposite charge. Plus 10 coulombs on the top plate, it automatically means what? Minus 10 coulombs on the bottom plate. Okay. So now Q, Vc is what? The voltage across the cap, and Q is what? The charge stored in the capacitor. Charge stored in the capacitor. Q is what? The charge stored in the capacitor. To be precise, Q is what? The magnitude of the charge stored in the capacitor. Because what is the net charge stored in the capacitor? Please comment in the chat box. For this parallel plate capacitor, what is the net amount of charge stored in both the plates? When I say net charge stored in the capacitor, it is what? Net charge stored in both the plates. What is the answer? Please type in the chat box. What is the net charge stored in the capacitor? Net charge 0. Net charge is what? 0. Because the top plate and the bottom plate both carry what? Equal and opposite charge. Equal and opposite charge. Earlier example, I told you what? Let's say the top plate contains what? Plus 10 coulombs. Then the bottom plate will contain what? Minus 10 coulombs. What is the total charge on both the plates? Plus 10 coulombs added with minus 10 coulombs. The sum is what? Always 0. So for the capacitor, the net charge is what? Always 0. Net charge is what? 0. So this Q, it does not represent or it does not denote the net charge stored in the capacitor, because for a capacitor, net charge does not make any sense. So nobody talks about the net charge stored in the capacitor. So always this Q will stand for what? The magnitude of the charge stored on both the plates, or the magnitude of charge stored on each plate. Instead of saying both the plates, I should better say Q is what? The magnitude of the charge stored on each plate. I'll say it again. Q is what? Magnitude of the charge stored in each plate, or stored on each plate. Again, going back to the same example, top plate, I said it has what? A charge of plus 10 coulombs. Bottom plate will have what? A charge of minus 10 coulombs. Plus 10 coulombs, minus 10 coulombs. Magnitude, is it not same? 10 coulombs, right? So what is the magnitude of the charge stored on each plate? It is plus 10 coulombs, and that 10 coulombs is what is called the charge stored in the capacitor. So when I say charge stored in the cap, I am referring to what? The magnitude of the charge stored on each plate. Okay, this should be clear. So charge stored in the capacitor, the actual meaning of this line is what? It is the magnitude of charge stored on each plate. Magnitude of charge stored on each plate. You understood? Yes. So this obviously means the positive plate will have a charge of plus Q, and the negative plate will have what? A charge of minus Q. Plus Q, minus Q, for both of them, the magnitude is what? The same, and it is what? Q. Okay. So this means positive plate will have a charge of what? Plus Q, and the negative plate will carry a charge of what? Minus Q. So for both the plates, the magnitude of charge is what? The same Q, and Q is what? The charge stored in the capacitor. So charge stored in the cap will always represent the magnitude of the charge stored on each plate. Okay. Now for any capacitor, the amount of charge stored, that is what? The value of Q, amount of charge stored in the cap, will be related to the applied voltage across the cap. In general, for any capacitor, if you increase the voltage across the cap, then the amount of charge stored in the cap also will increase. Okay. So in general, in general, as VC increases, in general, as VC increases, what is this VC? Voltage applied across the cap. If it increases, then the amount of charge stored in the cap also will increase. So this will lead to an increase in the charge stored in the capacitor as well. Now, for different capacitors, the relation between Q and VC will be odd different. Now, for a parallel plate capacitor, this Q, which is the charge stored in the cap, is directly proportional to what? The voltage across the cap. What is it? For a parallel plate capacitor, the charge stored in the cap, that is what Q, it is directly proportional to what? The voltage across the cap. Charge stored in the cap is directly proportional to what? The voltage across the cap. Q proportional to VC. Is it not a linear relationship between the charge and the voltage across the cap? Yes. So this parallel plate capacitor, it is what? An example for a linear capacitor. It is what? An example for a linear capacitor. And luckily, all the capacitors we will come across in this course are going to be what? Parallel plate capacitors, which means what? They are going to be linear capacitors. So if this is a linear capacitor, then you should also be having the more general case where Q can depend on VC in any arbitrary fashion. Okay, that means, look at this. Let us say Q is what? Proportional to VC power 3 by 2. Q is what? There is some capacitor, not the parallel plate capacitor, there is some other capacitor for which the charge stored in the cap depends on VC, like this. Q proportional to what? VC power 3 by 2. Is it a linear relationship? No, right? Linear relationship, it means what? Q should be proportional to what? VC power 1. Q should be proportional to what? VC power 1. So here, going back to the parallel plate case, where Q is what? Proportional to VC. When I write VC, it is understood that it is what? VC power 1. And that is why it is what? Linear. Okay. But if it depends on VC power anything other than 1, if the charge stored in the cap is directly proportional to what? VC power anything other than 1, then that relation is no longer going to be linear. Even in this case, Q proportional to what? VC power 3 by 2, it is what? Linear. Or let's say there is some other capacitor in which Q is proportional to what? 1 by square root VC. Q is proportional to what? 1 by square root VC. Then also it is what? A non-linear capacitor. Or let us say Q is what? Proportional to VC square. Again, Q proportional to what? VC square. VC square, is it not VC power 2, which is different from 1? So all these capacitors, they are considered to be non-linear capacitors. Okay. This is so whenever Q is proportional to what? VC power anything other than 1. Whenever Q is what? Proportional to VC power anything other than 1, then such a capacitor will be treated as what? A non-linear capacitor. But for all the capacitors we will come across in this course, Q is what? Proportional to VC power 1, or simply Q is what? Proportional to VC, and all those capacitors are going to be linear capacitors. Linear capacitor. So linear capacitor, it means what? Charge proportional to voltage. Okay, that's all. So all of you know, this is the circuit symbol for a capacitor. Just like for a resistor, you have a symbol. Even for the capacitor, we have a symbol. And this is the schematic symbol for a capacitor. And every capacitor, and let us say it is what? A parallel plate capacitor. So this one is what? This one, let it be a parallel plate capacitor, and let Vc be the voltage applied across the capacitor. Then because it's a parallel plate capacitor, Q is proportional to what? Vc. Q is what? Proportional to Vc. Now to get rid of this proportionality, you should introduce some constant of proportionality, and that constant of proportionality is what is called the value of capacitance of the capacitor. So what is this C called? It is called capacitance, okay? So Q equal to CV, there is something you must have studied many years ago, probably in your high school or even in +2, okay? Whatever it is, Q equal to CV is what? It's a very familiar relationship which is valid for any parallel plate capacitor, okay? So Q equal to what? C times Vc, where C is what? The value of capacitance. And the units for capacitance, they are what? Farads. Capacitance is measured in what units? It is measured in the units of farads, okay? So what does capacitance value tell you? Capacitance will tell you the ability of a capacitor to store charge. So for a given voltage applied across the cap, how much charge will be stored in the cap? That will be governed by the value of capacitance. And for a parallel plate capacitor, for a parallel plate capacitor, C is what? Epsilon A by D. I mean, this is not really necessary, but just for the sake of completeness, C is what? Epsilon A by D, where epsilon is what? The permittivity of the dielectric or the insulating material present between the two plates. A is what? Area of each plate. A is what? Area of each plate. There are two plates, right? Two parallel plates. Each plate will have some area. A is what? Area of each plate. D is what? The distance between the two plates, epsilon A by D. That will give you what? The value of the capacitance, okay? And Q is equal to what? C into Vc. Now, Q equal to what? C into Vc. If you differentiate both sides with respect to what time? Let us differentiate both sides of this equation with respect to what time? What do you get? dq by dt. Remember, for a given capacitor, the value of capacitance is what? Fixed. Because C is what? Fixed. Right hand side derivative with respect to time, it would be what? C dvc by dt. So dq by dt is what? C times dvc by dt. Now what is this dq by dt? Is it not the rate of flow of charge or rate of change of charge? How will charge change? Only when current will flow. Yes or no? Because current is what? Rate of flow of charge. This dq by dt is nothing but IC. dq by dt is what? IC. IC is what? Current through the capacitor flowing from plus to minus. Vc is what? Voltage across the cap. And IC is what? Current through the cap flowing from plus to minus. Then IC will be given by C times dVc by dt. So IC is equal to what? C times dVc by dt. This is the relationship between the current and the voltage. This is the relationship between the current and the voltage for any capacitor. For a resistor, what is it? V equal to IR, or I is equal to what? 1 by R into V. Just like for a resistor, we have what? V equal to IR. For a capacitor, what is that relation between current and voltage? IC, that is what? Current through the cap, is equal to C times dVc by dt. What is the meaning of dVc by dt? What is the meaning of dVc by dt? d by dt of anything. d by dt of anything means what? Rate of change. Let us say I say dx by dt. If I say dx by dt, it means what? Rate of change of x. If I say dy by dt, it means what? Rate of change of y. And now we have what? dvc by dt. dvc by dt, is it not the rate of change of voltage across the cap? That's all. dVc by dt. It is what? Rate of change of voltage across the cap. Rate of change of voltage across the cap, that is the meaning of dVc by dt. And here this dVc by dt, which is what? The rate of change of voltage across the cap, is it not equal to IC by EC, where IC is what? The current through the cap, and C is what? The value of capacitance of the capacitor. So IC equal to what? C dVc by dt, and dVc by dt can be written as what? IC divided by C. Now this capacitor, is it a linear circuit element or a non-linear circuit element? You know, resistor is what? Linear circuit element. But voltage source and current source both are what? Non-linear circuit elements. Yes or no? Independent voltage source and also the independent current source both are non-linear circuit elements. Now my question is what? What about this parallel plate capacitor? What about the parallel plate capacitor? Is it a linear element or a non-linear element? How do you decide if any element is what? Linear? The current must be linearly related to the voltage. For a resistor, any resistor obeys what? Ohm's law. What is that Ohm's law? Voltage proportional to what? Current. Yes or no? Ohm's law is what? Voltage proportional to current. Voltage proportional to current, clearly it is what? A linear relationship. Directly we can say a resistor is what? Linear. But for a capacitor, what is the relation between the current and the voltage? IC is equal to what? C dVc by dt. So now my question is the capacitor a linear circuit element or a non-linear circuit element? Please comment in the chat box. What do you think about the capacitor? Is it a linear element or a non-linear element? Okay, everybody is saying non-linear, but capacitor is what? It's a linear element. Capacitor. So you might be saying it is linear because of the current voltage relationship. IC, it depends on what? The derivative of the voltage, and it is not really directly proportional to the voltage. IC is what? Dependent on dVc by dt. That is why all of you are saying it is what? Non-linear. But the fact is what? Capacitor, just like resistor, it is also a linear circuit element. Okay, and the reason for that is what? This relation, is it not a linear differential equation? IC equal to what? C dVc by dt. It is what type of equation? It is what? Linear differential equation. Because it's a linear differential equation, even the capacitor, it is going to be linear. What is the test of linearity? When I explained linearity in one of the previous sessions, I told you what? There is something which can be used to check if any system is what? Linear or non-linear. What is used to find out, or what test is used to find out if any system is what? Linear or non-linear? Please comment. What is the test of linearity? What is the test of linearity? How do you find out if any system is what? Linear or non-linear? Superposition. Very good. Yes or no? Using, just by checking whether superposition is what? Satisfied or not, we can decide if any given system is what? Linear or non-linear. Okay. So let us apply the superposition test to determine whether the capacitor is what? Linear or non-linear. Now what is that superposition? You take the system, you apply some input x1, you will get some output y1. For the same system, you apply another input x2, you will get some other output y2. So for x1 we get what? Y1. For x2 we get what? Y2. Now again take the same system, and if you apply what x1 plus x2, then the output must be what y1 plus y2. In that case, the system is what said to be linear. We'll do the same thing for the capacitor as well. So once again, let this be a capacitor whose value of capacitance is what C, and Vc is what the voltage across the capacitor, and Ic is what the current through the capacitor flowing from plus to minus. Then you know the relation between Ic and Vc is what Ic equal to C dVc by dt. Ic equal to what C dVc by dt. Now let us say for the capacitor, the applied voltage is what Vc1 for the capacitor. Let the applied voltage be Vc1, and let the resulting current in this case be some Ic1, and you know Ic1 will be equal to what C times dVc1 by dt. Now again let us take the same capacitor, and this time let us apply a different voltage, let it be Vc2, and let the resulting current through the capacitor be some Ic2. Again Ic2 will be equal to what C times dVc2 by dt. Now again you take the same capacitor of value C. This time let the applied voltage across the cap be some Vc1 plus Vc2. First case we applied what Vc1, the current is what Ic1. Second case we applied Vc2, the current is what Ic2. Third case the applied voltage across the cap is what Vc1 plus Vc2. Let us call the current in the third case as what Ic3. So what is Ic3? Ic3 will be equal to what? See, always for a capacitor, the current will be equal to what? C times d by dt of the net voltage across the cap. C times d by dt of the net voltage across the cap. This time in the third case, what is the net voltage across the cap? Vc1 plus Vc2. So C times d by dt of Vc1 plus Vc2. Now this C times d by dt of Vc1 plus Vc2, can it not be split into what? Sum of two terms, and it can be written as what? C times dVc1 by dt plus C times dVc2 by dt. C times dVc1 by dt plus C times dVc2 by dt. Now you know C times dVc1 by dt, is it not Ic1? And look at the second term, it is what? C dVc2 by dt. Again C dVc2 by dt is nothing but Ic2. So the first term is what? Ic1, second term is what? Ic2. So Ic1 plus Ic2, and this is what? Ic3. So what did we get finally? Ic3 equal to what? Ic1 plus Ic2. Is it not superposition? Yes or no? When you apply x1 plus x2, and if the output turns out to be y1 plus y2, then definitely the system is what? Linear. Here also, when we applied Vc1 plus Vc2 voltage across the cap, resulting current is what? The sum of the two previous currents, which is Ic1 plus Ic2. So the capacitor as a circuit element, it is what? Linear. Okay. So this means capacitor is what? Linear. I hope it is understood as to how the capacitor is what? Linear circuit element. Clear, right? Yes. So once again, let's say we have a capacitor of value C, across which the voltage drop is what? Vc, and the current through the cap is what? Some IC, and we already know IC equal to what? C dVc by dt. IC equal to what? C dVc by dt. You see, IC equal to what? C dVc by dt. Is it not current in terms of voltage? Do you all agree with that? When I say, or when we write the equation as what? IC equal to C times dVc by dt, it means what? We are expressing current in terms of voltage. Okay. What is it? Current in terms of voltage. So in brackets, I'll write, this is what? Current in terms of voltage. So if you know the voltage across the cap, one can always find the current through the cap just by using this equation, C times dVc by dt. Now from this equation, let us find the voltage across the cap in terms of the current through the cap. Let us find the voltage across the cap in terms of the current through the cap. Okay. Look at this. I mean, it is just a matter of manipulating this equation so as to express voltage in terms of current. So what is our objective? Already we know current through the cap in terms of what? Voltage. Now we are trying to find or express the voltage across the cap in terms of what? The current through the cap. So now we are going to find voltage in terms of current. Voltage in terms of what? Current. Now again, IC equal to what? C dVc by dt. It can be written as what? dVc by dt equal to what? IC by C. Equal to what? IC by C. Now this dt will go to the other side. You will get dVc is equal to what? IC by C times dt. dVc equal to what? IC by C times dt. What is our goal? It is to find Vc in terms of IC, and right now the equation contains what? dVc. Just have to integrate on both the sides. Just have to integrate on both the sides. And let us say we would like to find Vc as a function of time. We would like to find Vc as a function of time. So what are the limits of the integral on the right hand side? Right hand side, the integration, is it not with respect to time? Yes, on the right hand side the integration is what? dt. That means what? Integration is with respect to time. Left hand side the integration is what? With respect to the voltage across the cap, that is what? Vc. Now you know time will vary from minus infinity up to the present instant, that is what? T. So always T is what? The current instant. T is what? The current instant or the present instant. Okay. So T varies from minus infinity up to the current instant, that is what? T. You understood? Yes. A time varies from minus infinity up to the current instant, that is what? T. Now if the time varies from minus infinity up to T, then obviously even the voltage across the cap should vary from voltage across the cap at t equal to minus infinity up to voltage across the cap at the current instant, which is what? Vc of t. I hope you are following. So Vc of minus infinity up to Vc of t. Please note it down up to this point. So left hand side, first right hand side, the limits of the integral with respect to time are what? Minus infinity up to t. Because the time varies from minus infinity up to t, Vc should vary from Vc at t equal to minus infinity up to Vc at t. You understood? Yes. What is the integration of dVc? What is the integration of dVc? Integration of dVc, is it not simply Vc? And then if you substitute or plug in the upper limit and the lower limit, always first you should plug in the upper limit, then you should plug in the lower limit, take the difference between upper limit and the lower limit, yes or no? So left hand side, if you do the integration, won't you get Vc of t minus Vc of minus infinity? Yes. Vc of t minus Vc of minus infinity. Vc of t minus Vc of minus infinity is equal to what? Integration of Ic by c dt from minus infinity up to t. From minus infinity up to t. I hope it is clear up to this point. Vc of t minus Vc of minus infinity is equal to what? Integration of Ic divided by c. Ic is what? Current through the cap divided by the value of the capacitance, and the integration on the right hand side is carried from t equal to minus infinity up to t equal to what? T. Okay. Now what is this t equal to minus infinity? What is t equal to minus infinity? See, t equal to minus infinity, it is like the beginning of time. Yes or no? T equal to minus infinity is what? Like the beginning of the universe or the beginning of time. So when the universe started, let's say with the Big Bang and so on, when the universe started, everything started from zero. Yes or no? So always we'll assume that the value of any voltage or any current or any variable at the beginning of universe, that is what? At t equal to minus infinity is going to be zero. And starting from zero, the universe, it kept on expanding, and now we are here. Yes or no? That is why Vc of minus infinity, we will assume it is what? Zero. I hope my logic is clear as to why I am saying Vc of minus infinity is what? Zero. Yes. So that is like the first point. So Vc of Vc of minus infinity, it is always going to be 0. If Vc of minus infinity is what? 0, then left hand side, what is left? Only Vc of t, because Vc of minus infinity is what? 0. What is left? Only Vc of t. And Vc of t is equal to what? Integral minus infinity to t Ic by c dt. Now this c, is it not a constant value of capacitance? It is what? A constant. We can as well bring this c outside of the integral and write it as what? 1 by c integral Ic dt from minus infinity up to t. So in textbooks you will find this expression, that is what? 1 by c, which is written outside of the integral, because after all c is what? A constant. So 1 by c integral minus infinity to t Ic of t dt. Remember, Ic itself can be a function of time. Ic itself can be what? A function of time. So I hope it is clear up to this point. Vc of t, that is what? Voltage across the cap at the present instant, is equal to what? 1 by c multiplied with integration of the current from minus infinity up to the present instant. Integration of current. Look at the current. It depends on the time derivative of voltage. Current, it depends on time derivative of voltage. Ic depends on what? dVc by dt. Current is related to what? The rate of change of voltage across the cap. Whereas the voltage, it is related to what? The time integral of the current. That is the small observation one can make. Current depends on the time derivative of the voltage, whereas the voltage depends on the time integral of the current. And remember, integration means what? Finding area. Differentiation means what? Finding slope. Rate of change is what? Slope. Integrating means what? Finding area under the function. In fact, here, look at the limits of the integral minus infinity up to t. That means what? If you have the current waveform, you should integrate the current waveform from minus infinity up to the present instant. You should find the area under the current waveform from minus infinity up to the present instant to find the voltage across the gap at the present instant. So if you want to find voltage across the gap right now, you should find the area under the current waveform from minus infinity up to the present instant. Once you find the area under the current waveform, multiply it with 1 by C, then you will get the voltage across the cap right now at the current instant. I hope it is clear. Please note it down up to this point. We will break this down into two separate parts, and that will make things even more clear. What is Vc of t right now? It is 1 by C integral minus infinity up to t Ic of t dt. Okay. So what did we get for Vc of t? Vc of t is what? 1 by C integral minus infinity to t Ic of t dt. Ic of t dt. Okay. Okay, right now what is the time? It is 8:13. Let us say 8:15. Let us say 8:15. That means what? This t is what? The present instant, which is 8:15. And let us say our circuit has started at 7 o'clock. Our circuit has started at 7 o'clock, and now the time is what? 8:15. So how much time has gone by since the circuit has started? Circuit started at 7 p.m. Now we are at 8:15 p.m. 1 hour 15 minutes have gone by after the circuit has started. You understood, right? So the point I am trying to make is what? Whenever the circuit starts, whenever our circuit starts, that point is assumed to be t equal to 0. Whenever the system starts, that point of time is assumed to be t equal to 0. You understood? Our circuit started at 7 o'clock. 7 p.m. Our circuit, I am saying what? It starts at 7 p.m. Then 7 p.m. will be what? T equal to 0. So what is t now? Tell me what is t now? I am saying 7 p.m. is what? T equal to 0. Now it is what? 8:15. Now the time is what? 8:15. So what is t? Circuit starts at 7 p.m. Now the time is what? 8:15. What is t? 1 hour 15 minutes. T is what? 1 hour 15 minutes. 1 hour 15 minutes is what? I think 75 minutes. Yes, very good. Understood, right? Yes. All circuits are assumed to start at t equal to 0. But for the capacitor, something could have happened before 7 p.m. Listen carefully. I am saying what? Circuit starts at 7 p.m. But for the capacitor, something must have happened before 7 p.m. Before 7 p.m. Is it t greater than 0 or t less than 0? T less than 0. Yes, and after 7 p.m. is what? T greater than 0. Now is what? T greater than 0. 7 p.m. is what? T greater than t equal to 0. So before 7 p.m. that is what? T less than 0. Before 7 p.m. is what? T less than 0. 7 p.m. is what? T equal to 0. And now we are at t greater than 0. You understood? Yes. So it's Vc of t. This Vc of t, which is 1 by C integral minus infinity to t Ic of t dt. This can be written as what? 1 by C integral minus infinity up to 0. Minus infinity up to 0 Ic of t dt plus 1 by C integral 0 to t Ic of t dt. Do you agree with this? Integration from minus infinity to t has been broken down into what? Two separate integrals. One from minus infinity up to 0, another from 0 up to t. So it is like this. Let me show the timeline. Sorry. So let's say this is what the timeline. Okay. Now in this timeline, let this be t equal to what? Minus infinity. Let this be t equal to what? 0. And let this be t. Let this be t. Now, from minus infinity to 0, yes, our circuit starts at t equal to what? 0. But for the capacitor, something can, anything can happen for t less than 0. See, if you are born today, whatever happened before you were born, is it not history for you? Yes or no? If you are born today, if somebody is born today, whatever happened till yesterday, that is what history. In the same way, our circuit starts at what? T equal to 0. So whatever happened to the capacitor for t less than 0, that is like history of the cap. That is what? The history of the capacitor. 0 to t, is it history or present? Circuit starts at t equal to 0. T greater than 0 is what? Present. T less than 0 is what? Past or history. Okay, the first term, look at the first term, 1 by c integral minus infinity up to 0 Ic of t dt. So this first term represents what? The history of the capacitor. This first term represents what? History of the capacitor. Okay, this one is what? History. This is what? Present. I hope you are able to understand what I am trying to get at. Okay. So the point is what? This term will represent what? The history of the capacitor. History of the capacitor. In fact, how do you get only the first term? How do you get only the first term? Take the original equation for Vc of t, which is 1 by c integral minus infinity up to t Ic of t dt. If you put t equal to 0, left hand side will be what? Vc of 0, and right hand side will be what? 1 by c integral minus infinity up to 0 Ic of t dt. And look at this term, history of the cap, 1 by c integral minus infinity up to 0 Ic of t dt. Up to 0, is it not Vc of 0? The first term is what? Vc of 0. So this is what? Vc of 0. That's all. So the entire first term, which will represent what? The history of the capacitor. So which value will have all the information about the history of the capacitor? It is Vc of 0. It is what? Vc of 0, which will have or which will store information about the history of the capacitor, meaning what happened to the capacitor before the circuit has started at t equal to 0. All that information is present in the first term, which is what? Vc of 0. I hope it is clear. Okay. And remember, our circuit starts at t equal to 0. You see, because our circuit starts at t equal to 0, see, if anything that starts at a certain point in time, at the starting point, whatever you have, is it not the initial value? Yes or no? At the starting point. Starting is also what? Initial, right? Starting is also called as initial. Okay. Circuit starts at t equal to 0. At t equal to 0, what is the voltage across the cap? Vc of 0. So Vc of 0 is what? The initial voltage across the cap. Okay, Shiv Sainath, sir, please once again explain why we took as Vc of 0. Okay, all of you please look at the screen carefully. Take the first equation. Shiv Sainath, please take the first equation. If you put t equal to 0, what do you get? Left hand side, will it not be Vc of 0? And right, remember this t and this t both are one and the same. Yes or no? I am asking you what? To substitute t equal to 0. If you put t equal to 0, left hand side will be what? Vc of 0. Right hand side will be what? 1 by c integral minus infinity up to 0 and then Ic of t dt. Yes. And even this term is what? Same thing. 1 by c integral minus infinity up to 0 Ic of t dt. That is why the first term is called as what? Vc of 0. Understood? Yes. Okay. When is our circuit starting? Our circuit is starting at t equal to 0. So when the circuit is starting, the voltage across the cap will have some value. That value, the voltage across the cap, when the circuit starts, is what? Vc of 0. Because Vc of 0 is what? Voltage across the cap at t equal to 0. Yes. And t equal to 0 is also the instant when the circuit will start. So from now onwards, Vc of 0 will be called as what? The initial voltage across the cap, assuming circuit starts at t equal to 0. Yes, let us say there is some circuit which starts at t equal to what? 10 seconds. There is some circuit which starts at t equal to what? 10 seconds. then the voltage across the cap at 10 seconds will be what? The initial value. Understood? Whenever the circuit is starting and when the circuit starts, there will be some voltage across the cap. So the voltage across the cap at the starting point of the circuit will be called as what? The initial voltage across the cap. And our circuit starts at what? T equal to 0. So voltage across the cap at T equal to 0 from now onwards will be called as what? The initial voltage across the cap. Okay. So Vc of 0, it is called as what? Initial voltage across the cap. Vc of 0 is what? The initial voltage across the cap. Understood? Yes. Now what will this equation become? Vc of t. The entire first term is what? Vc of 0. Entire first term is what? Vc of 0. Then we have the second term, which is 1 by c integral 0 to t. You see, the first term is going to account for, the first term will account for what happened to the capacitor before the circuit starts at t equal to 0. That is what? History. Second term will represent what happened to the capacitor after the circuit has started at t equal to 0. That means for t greater than 0, what is happening to the capacitor, that information will lie in the second term. Okay. This is what happened to the cap before t equal to 0. That is what? History, or the past information about the cap. So this entire thing is what? Vc of 0, and this thing is what? 1 by c integral 0 to t Ic of t dt. That's all. This is the final expression for the voltage across the cap in terms of what? Current through the cap. This is the final expression for the voltage across the cap in terms of the current through the cap. Vc of t is what? Vc of 0. Of course, we are assuming that the circuit starts at what? T equal to 0 and so on, and we are trying to find voltage across the cap at any instant, which is what? Greater than t greater than 0. Okay. So Vc of t is what? Vc of 0 plus 1 by c integral 0 to t Ic of t dt. I hope this is clear. Okay. So let me write both the equations at 1 plus. First is what? Current in terms of voltage. What is current in terms of voltage? Ic is equal to what? C dVc by dt. And the second thing is what? What is voltage across the cap in terms of current? What is the voltage across the cap in terms of the current? What did we get? Just now we obtained Vc of t equal to what? The initial voltage across the cap, that is what? Vc of 0 plus 1 by c integral 0 to t Ic of t dt. Yes. First is what? Current in terms of voltage. Second one is what? Voltage in terms of current. Vc of t is what? Vc of 0 plus 1 by c integral 0 to t Ic of t dt. Understood? Yes. And remember, in these two equations, Ic, it is always what? The current flowing from plus to minus. Okay. And Vc is what? The voltage across the cap. So let us say we have a capacitor. Let's say we have a capacitor across which the voltage drop is what? Vc. and let the current flowing from plus to minus be some IC. Let us consider three cases, okay? So in the first case, let us say IC is what, 0. Let us say IC is what, 0. Yes. If IC is 0, please tell me what is dVc by dt. IC is 0, it means what? No current is flowing through the cap. IC is 0, it means what? No current is flowing through the cap. What is the value of dVc by dt? You know, IC is what? C dVc by dt. Yes or no? IC is what? C dVc by dt. So what is dVc by dt in terms of IC? IC divided by C. Yes or no? So listen carefully. I am saying what? In the first case, the current through the cap is what? 0. If IC is 0, always dVc by dt is what? IC divided by C, that is also 0. dVc by dt is 0. What does it mean? Rate of change of voltage across the cap is what? 0. What does it mean? Rate of change of voltage across the cap 0. It means voltage is what? Constant. If the rate of change of anything is what? 0, that thing is not changing with time. Very good. Vc, it remains constant. Okay, this means Vc remains constant. So whenever the current through any cap is what? 0, you should not say voltage across the cap will be 0. You should say voltage does not change, or rather the voltage across the cap remains constant. I mean, this is unlike what we have for a resistor. For a resistor, if current is 0, voltage drop is what? 0. Or if voltage is 0, current is what? 0. But for a capacitor, if the current is 0, voltage drop will remain constant. It can be any constant value. It can be 0, it can be a positive value, it can be a negative value, but it does not change as long as the current through the cap is what? 0. So whenever voltage across the cap is what? Constant, that will happen only when the current through the cap is what? 0. Just keep this in mind, okay? Now the other possibility is what? IC can be greater than 0. Yes or no? A positive current can flow through the capacitor from plus to minus. Yes or no? IC greater than 0. If I should describe it in words, I must say we have a positive current flowing through the capacitor from plus to minus, because IC is what? Flowing from plus to minus, and here in the second case IC is what? Positive. We have a positive current flowing from plus to minus, okay? If you have a positive current flowing from plus to minus, what about dVc by dt in this case? Always dVc by dt is what? IC divided by C. Always dVc by dt is what? IC divided by C. And in the second case, IC is what? Greater than 0, that is what? Positive. IC positive, value of capacitance of any parallel plate capacitor is also what? Positive. IC positive, C positive, IC by C is also what? Positive. That means dVc by dt is what? Positive. dVc by dt, rate of change of voltage across the cap, is it not positive? If the rate of change of anything is what? Positive, then that means what? That thing is increasing with time. And here dVc by dt is what? Greater than 0 or positive. That means the value of Vc will increase with time. So this means Vc is what? Increasing with time. Vc is what? Voltage across the cap increasing with time. Voltage across the cap increasing with time, it means what? Capacitor is getting charged. From now onwards, very frequently we will say that so and so cap is what? Getting charged, or so and so cap is what? Getting discharged, and so on. Cap getting charged, it only means what? The voltage drop across the cap, it is increasing with time. Cap getting discharged, it means what? Voltage across the cap, it will reduce with time. But in the first case, Vc remains constant. It is neither increasing nor decreasing. That means what? Neither getting charged nor getting discharged. So in the second case, what should we say about the cap? Is it going to get charged or discharged? Charged. Yes or no? Because VC is what? Increasing with time. VC increasing is what? Getting charged. So in the second case, we must say cap is what? Getting charged. Cap is what? Getting charged. What is the only other possibility or only other case? The same IC can be what? Negative. The same IC can be negative. Okay. Once again, you see always dVC by dt is what? IC by C. Always dVC by dt is what? IC by C. And right now IC is what? Negative. If IC is negative, IC by C will also be negative. That means dVC by dt is also going to be negative. Again, dVC by dt is what? Rate of change of voltage across the cap. Rate of change of voltage across the cap negative. That means what? Rate of change negative, it will decrease. Rate of change positive, it will increase. Previous case, rate of change is what? Positive. And that means VC is what? Increasing with time. But now rate of change is what? Negative, which means VC is going to decrease with time. Okay. So in the third case, VC will decrease with time. VC increasing with time is what? Cap getting charged. And VC decreasing with time, it means what? Cap is getting discharged. Okay. So in the third case, we must say cap is what? Getting discharged. Cap is what? Getting discharged. So for any capacitor, always you have only three possibilities. For any cap, you will have only three possibilities. What are the three possibilities? The cap will remain, or the cap voltage will remain constant. When will that happen? When the current through the cap is what? Zero. And what are the other two possibilities? Either the cap can get charged or it can get discharged. When will it get charged? When you have a positive current flowing from plus to minus. When you have a positive current flowing from plus to minus, cap will get discharged, meaning the value of VC will increase with time. When will cap get discharged? When will cap get discharged? When you have a negative current flowing from plus to minus. Please keep this in mind. Cap will get discharged when you have a negative current, IC less than 0, that means what? IC is negative. When you have a negative current flowing from plus to minus. You see, negative current flowing from plus to minus, is it not same as positive current flowing from minus to plus? Do you all agree with that? Negative current flowing from plus to minus is same as what? Positive current flowing from minus to plus. Cap will get discharged. Positive current flowing from plus to minus, cap will get charged. Okay, these 2 points should be very clear. So if you know these 2 points clearly, just by looking at the cap, you can decide whether any cap will get charged or discharged. Okay, positive current flowing from plus to minus, cap will get charged. Positive current flowing from minus to plus, cap will get discharged. I hope these 2 statements are clear. Okay. So what is it? For the cap, there are 3 possibilities. Either the voltage will remain constant or it might get charged or discharged. Okay, when will it get charged? When you have a positive current flowing from plus to minus. And when will it get discharged? When you have a positive current flowing from minus to plus. Okay. Just tell me, in this case, the cap will get charged or discharged. Just type in the chart box whether the cap will get charged or discharged in this case? So in both the cases, please tell me, in the first case, will the cap get charged or discharged? And also in the second case, will the capacitor get charged or discharged? Okay, charge and discharge. Very good. First case charging, second case discharging. You see, if you look at the first case, what is the current through the cap? It is minus 5 amps. Minus 5 amps in the downward direction. Is it not same as plus 5 amps in the upward direction? Yes. And look at this plus 5 amps flowing in the upward direction. So are we not having a positive current entering the plus terminal? Yes or no? Positive current entering the plus terminal, cap will get charged. Okay. So always you have to look at the plus terminal. I'll say it very clearly. Just look at the plus terminal. At the plus terminal, if a positive current is what? Entering the element, then the cap will get charged. And at the positive terminal, if a positive current is what? Leaving the element or the capacitor, then the cap will get discharged. Okay. In this case, at the positive terminal, that is what? At the bottom terminal, you can see 5 amps, which is what? Positive. Is it not entering the capacitor? So cap will get charged. Okay. So whenever a positive current enters at the plus terminal, cap will get charged. Now coming to the second case, what is the current through the cap? It is given as minus 10 amps. Look at the direction of minus 10 amps. Minus 10 amps is what? Flowing in the downward direction. Minus 10 in the downward direction, is it not plus 10 amps in the upward direction? Again, look at the plus terminal. So at the plus terminal, we have a positive current flowing out of the element. At the plus terminal, 10 amps is what? Flowing into plus or out of plus? If you look at the first case, 5 amps is what? Flowing into plus. But if you look at the second case, 10 amps, which is positive, it is flowing out of plus. Positive current flowing out of plus, cap will get discharged. Okay. Cap will get discharged. I hope everything is clear up to this point. Okay. So look at this simple circuit. We have a 2 volt source across which a capacitor is connected, not directly but through a switch. So this thing is what? It's a switch. And what is happening to the switch? It is being closed. Can you all see that? This switch, it is what? Being closed at t equal to 0. So before t equal to 0, switch is what? Open. At t equal to 0, switch is what? Closed. And for t greater than 0, switch will remain closed. So t less than 0, switch is what? Open. And t greater than 0, switch is what? Closed. Okay. Now what happens to the capacitor when you close the switch? See, when you close the switch, the capacitor, does it not appear directly across the voltage source? When you close the switch, capacitor will be directly connected across the voltage source. If any element is what? Directly connected across any voltage source, the voltage source value will directly go to that element, because 2 elements in parallel will always have the same voltage drop. So you already know that when you close the switch, immediately the value of VC becomes what? 2 volts. Immediately the value of VC, it becomes what? 2 volts. Do you all agree with that? When you close the switch, the capacitor will come directly across the voltage source or will be connected directly across the voltage source, which means whatever value of voltage the voltage source has, the same voltage will go to the capacitor. Immediately VC will become what? 2 volts. Okay. So here immediately after closing the switch, the value of VC, it becomes what? 2 volts. the value of AC, it becomes what? 2 volts. Do you all agree with that? Yes. So when you close the switch, immediately the value of AC becomes what? 2 volts. Okay. Now let us say the value of the capacitance, it is some 2 farad. Let us say the value of the capacitance, it is some 2 farad. Okay. If the value of the capacitance is what? 2 farad. Can you tell me what is the charge stored in the capacitor after closing the switch? What is the charge stored in the capacitor immediately after closing the switch? Immediately after closing the switch, voltage across the cap becomes what? 2 volts. Q is equal to what? C times Vc. Yes or no? Charge stored in the cap is what? C times Vc. Did you say 4? 4 coulombs, right? Very good. So immediately after closing the switch, cap will get charged to what? 2 volts, and the amount of charge stored in the cap is what? 4 coulombs. C is what? Coulombs. Okay, 4 coulombs. Now you know both this Q, which is what? 4 coulombs. It is not the total charge on both the plates. It is what? The magnitude of the charge stored on each plate. This Q is what? Magnitude of the charge stored on each plate. So if the charge stored, or if the magnitude of the charge stored on each plate is what? 4 coulombs, it means the top plate, is it not positive? Because top plate is connected to what? Plus of the battery, top plate will be what? Positive. Bottom plate connected to what? Negative of the battery, bottom plate will be what? Negative plate. Always the top plate and the bottom plate will carry what? Equal and opposite charge. Already we know the magnitude of the charge is what? 4 coulombs. Okay. So be clear that this 4 coulombs, it is actually what? The magnitude of the charge stored on each plate. So if you take the top plate, which is what? Positive, what is the amount of charge stored on the top plate alone? Will it not be plus 4 coulombs? It will be what? Plus 4 coulombs. Let me write it cleanly. So there is how much? Plus 4 coulombs. In the same way, what is the amount of charge stored on the bottom plate? Bottom plate is what? Negative. Negative plate will carry what? Negative charge. Top plate is what? Positive. Positive plate will carry what? Positive charge. So what is the amount of charge on the bottom plate? Will it not be minus 4 coulombs? So top plate has what? Plus 4 coulombs of charge, and the bottom plate will have minus 4 coulombs of charge. Plus 4 coulombs and minus 4 coulombs. Are they not equal and opposite? Is it not true for any parallel plate capacitor? Always in any parallel plate capacitor, both the plates will carry what? Equal and opposite charge. Like in this case, plus 4 coulombs on one plate and minus 4 coulombs on the top plate. Now my question is, how will both the plates attain their respective charges? How is the top plate getting 4 coulombs or plus 4 coulombs, and how is the bottom plate getting minus 4 coulombs? That is my question. You can just type in the chat box whatever you think might happen. Please let me know. We'll take the discussion from there. So please tell me, how is the top plate getting plus 4 coulombs, and how is the bottom plate getting minus 4 coulombs? Okay, let me ask Dineshwaran. Okay, somebody said something. From Van de Graaff, no, don't complicate things. From positive terminal of voltage we get, and from we get top plate as. Okay, Shiv Sainath said something. From positive terminal of voltage. You mean to say voltage source will supply that plus 4 coulombs of charge? Shiv Sainath, is it so? So I think what you are trying to point out is what? That the plus of the battery will supply plus 4 coulombs to the top plate, and minus of the battery will supply minus 4 coulombs to the bottom plate. Others, what do you think? I mean, do you think this is correct? Because of flow of current. But can current really flow through capacitor? Okay, Uday Kumar is saying because of flow of current, which is correct. But can current flow through capacitor? Because in between the two plates, what do you have? Insulator. Through insulator, charges cannot move. Through insulator, charges cannot move. Okay. Well, at least you are trying to think, which is a very good thing. Okay, the no displacement current. Okay, within the capacitor, we have something called displacement current, and that is just for the sake of continuity. Okay. So now let me explain how the top plate will get plus 4 coulombs of charge and the bottom plate will get minus 4 coulombs of charge. First of all, see, voltage source, it only creates what? A potential difference. It does not supply charge on its own. So voltage source does not provide any kind of charge. You see, you can think of the voltage source as a water pump. I mean, we install motors, right? Underground motors to suck water from the underground. Yes. You see, let's say there is no water. There is no water, and still you install a pump. Will you get water? No. Only if you have water in the underground, and then the pump will create what? The motor will create what? Pressure difference, not potential difference. Pressure difference. Motor will create what? Pressure difference, due to which the underground water will come to the surface, which we can use for various purposes and so on. You understood? So just like the water pump, which will only create what? A pressure difference, so as to enable the flow of what? Water from underground up to the surface and so on. In the same way, even the voltage source, it only creates what? A potential difference, so that charges can move. Due to water pump, water will flow from high pressure to low pressure. Well, due to this voltage source, charges will move from high potential to low potential and so on. Yes. So if there is charge, only that charge will be moved because of the voltage, which creates what? A potential difference. Voltage source itself does not provide any charge. If already some charge is present, that charge will be moved because of the voltage or the potential difference. Okay, so the point is what? Voltage source by itself does not provide any charge. Okay, if charge is already present, that charge can be moved in some direction by applying voltage appropriately and so on. Okay, I am saying what for the capacitor? There are two plates. In this case, the top plate and the bottom plate. Now if you take any plate, plate is what? It's a piece of metal. Any plate, it is what? A piece of metal. And because it's a conducting plate, does it not contain plenty of free electrons? Any conducting plate will contain what? Plenty of free electrons. Okay. Now at the subatomic level, inside any atom, we have two types of charged particles. One is what? Electrons, which are negatively charged. Another is what? Protons, which are positively charged. If you take any atom is what? Neutral. Neutral, it means what? It contains equal number of protons and electrons. This is high school chemistry or high school physics. Yes or no? Any atom is what? Electrically neutral. Okay. So let us say this is what? A plate. And to start with, let us say this plate is what? Neutral. Neutral means what? Charged or uncharged? No charge. Neutral means what? No charge. Okay. So this plate, net charge is what? 0. Net charge, it means what? Inside the plate, the number of electrons is equal to what? Number of protons. That is why net charge is what? 0. You understood, right? When I say plate is what? Neutral, it only means what? Inside the plate, the number of electrons is same as what? Number of protons. Okay. Now you take this neutral plate. You take this neutral plate and let us add 100 electrons. Let us add 100 electrons. Initially, before adding the 100 electrons, the plate is what? Neutral. That means what? Equal number of electrons and protons. Let us say before adding the 100 electrons, let's say you have 1000 electrons and also 1000 protons. 1000 electrons and 1000 protons. What is the net charge? 0. And then you are adding what? 100 electrons. Now what is the net number of electrons? What is the net number of electrons after adding 100 electrons? Will it not be 1100 electrons but only 1000 protons? Is it clear up to this point? Very simple discussion. Okay. Starting plate is what? Initial. Plate is what? Neutral. Initially plate is what? Neutral. So equal number of electrons and protons. And to this plate we are adding what? 100 electrons. Now the net number of electrons is what? The existing 1000 plus the newly added 100, which makes it what? 1100 electrons. And still the number of protons is what? The same, 1000 protons. Okay. Now does it not mean the plate will be what? Positively charged or negatively charged? Please comment. After adding 100 electrons, will it not become negatively charged? Because 1100 electrons and 1000 protons, number of negative charges is what? More than number of positive charges. So the plate will be what? Having a net negative charge. Okay. So this means the plate will become negatively charged. I hope it is clear. So the point is what? If you add electrons to any plate which is initially neutral, the plate will become what? Negatively charged. Yes. Now again you take the same plate. Which is what? Initially neutral. Neutral means what? The net charge is what? 0. And just as an example, let us say the plate has got 1000 electrons and also 1000 protons. 1000 electrons and 1000 protons. And then what are we doing now? Let us take out 100 electrons from the plate. In the earlier case, we added 100 electrons to the plate. Now in the second case, let us take out or let us remove 100 electrons from the plate. Initial number of electrons is what? 1000, out of which 100 are being removed. Now what is the net number of electrons for the plate? Only 900 electrons. Okay. But the number of protons will remain unchanged. So still the plate will contain or will have what? 1000 protons. Okay. 1000 protons. So look at the net number of electrons and protons. Net number of electrons is what? 900, whereas the number of protons is what? 1000. Electrons are what? Negatively charged. Protons are what? Positively charged. Are we not having more positive charges as compared to negative charges? That means what? This plate will become positively charged. So what is the conclusion from these two cases? You take any plate, you add electrons onto the plate, you put electrons into the plate, that plate will become what? Negatively charged. You take any plate, you remove electrons from the plate, that plate will become what? Positively charged. Understood, right? Add electrons, that means what? See, adding electrons, it means what? You are adding negative charges. It will obviously become negatively charged. Yes. So when you add electrons to any plate, plate will become what? Negatively charged. And if you take out or remove electrons from any plate, that plate will become what? Positively charged. This is how the plates will become positively charged and negatively charged. Remove electrons, plate becomes positively charged. Add electrons to any plate, plate will become what? Positively add electrons to any plate, the plate will become negatively charged. I hope this is clear. Okay. Now let us go back to the previous example where we were trying to understand how the two plates will acquire plus 4 coulombs and minus 4 coulombs of charge respectively. Okay, and that is happening after closing the switch. Okay, look at this. After closing the switch, that means now the switch is what? Closed. When the switch is closed, only then the voltage source is what? Connected to the capacitor. Initially both the plates are what? Neutral. Now voltage creates what? Electric field. Voltage is what? Potential difference. Whenever there is what? Potential difference, it will create what? Electric field. What is the property of the positive terminal of any battery? What is the property of positive terminal of any battery? Positive terminal of any battery will always attract electrons. Positive terminal of any battery will attract electrons. Okay. Now look at the positive terminal of the battery. Positive terminal of the battery, is it not connected to the top plate? That means what? Plus of the battery or the positive terminal of the battery will attract electrons from the top plate. Positive attracting electrons from the top plate. That means what? This positive will suck out or remove electrons from the top plate. If you remove electrons from any plate, will it not become positively charged? That is how the top plate becomes what? Positively charged. Okay, so what is happening here? So from the top plate, electrons are being removed. Why? Because top plate is what? Connected to plus of the battery. Plus of the battery will always attract electrons. Okay, so in this case, plus of the battery will remove or attract electrons from the top plate. So the top plate becomes what? Positively charged. Yes. Now for the voltage source, what is happening now? Some electrons are coming out from the top plate. They are going to what? Plus of the battery. Now for a voltage source, whatever electrons flow into plus of the battery, the same electrons will come out at the minus terminal. Yes or no? Look at this. Whatever number of electrons are flowing into plus, the same electrons will again come out of what? Minus. Yes or no? Electrons going into plus, because voltage source does not store any electrons. Okay, whatever electrons flow into plus, the same electrons will come out at the other side. That is what? At the minus side. Now the same electrons will come out at the minus side, and look at these electrons. Are they not going to get deposited on the bottom plate? So what is happening here? This voltage source, it pulls out electrons from the top plate, and whatever electrons are pulled out from the top plate, the same electrons are being deposited on the bottom plate. So for the top plate, you are removing electrons. That is why top plate becomes what? Positively charged. But for the bottom plate, whatever electrons are removed from the top plate, only those electrons are being added to the bottom plate. If you add electrons to any plate, does it not become negatively charged? That is how the two plates become what? Positively charged and negatively charged. So is the voltage source applying any charge? No. Voltage source will only move the charge. In this case, voltage source is what? Redistributing electrons from the top plate to the bottom plate. And also look at the electrons. They are moving not within the capacitor. Electrons are moving outside the capacitor. That is what? In the external circuit, not between the two plates. Okay, electrons are removed from the top plate and they are being deposited on the bottom plate. What is the direction of electrons in the circuit? Clockwise or anti-clockwise? Please comment in the chat box. What is the direction of electrons in the circuit? What is the direction of flow of electrons in the circuit? Clockwise or anti-clockwise? Anti-clockwise. Do you all agree with that? Yes. Counterclockwise. Yes or no? Look at this. Electrons are flowing in the counterclockwise direction. Whenever electrons are flowing, does it not lead to current? Yes or no? Flow of electrons is what? Current. Flow of electrons is what? Current. Yes. What is the direction of current? Counterclockwise or clockwise? What is the direction of current? Clockwise. Because electrons are flowing in the anti-clockwise direction, current will flow in the clockwise direction. Very good. That's all. This is the direction of current. Understood, right? This is how the cap will eventually get charged to what? 4 volts. Isn't the cap getting charged to what? 2 volts? I should have said 2. Cap is what? Getting charged to 2 volts, which means voltage across the cap is what? 2 volts. But because the capacitance value is what? 2 farad, charge stored in the cap is what? 4 coulombs. Okay. So here electrons are flowing in the anti-clockwise direction. So the resulting current will flow in the clockwise direction. Okay. That's all. This is how any cap will go from one voltage to another voltage. So what is taking place here? Charge redistribution. Electrons will get redistributed between the two plates. Okay. Electrons are taken out from the top plate. The same electrons are being deposited on the bottom plate. So the top plate becomes what? Positively charged, and the bottom plate becomes what? Negatively charged. Okay. I hope everything about the capacitor is what? Clear so far. There is only a very elementary discussion of the capacitor. Tomorrow we'll look at a few more things about the capacitor. Then we'll look at the inductor. Okay, so tomorrow I'll start the class at 10:30 in the morning. I hope it is okay for everybody. So I'll see you tomorrow.